Okay, this is Monday, April 27th, 2020. This is the Year 12 Term 2 Physics Final revision. So the final will have 3 questions, and we will go over how to answer these questions in this video. Question number 1, it says, what is the acceleration of the object at t equal 12 seconds and t is equal to 48 seconds? So we have this velocity time graph with velocity in meters per second and time in seconds. And we see we have a curve. So this is an example of non-uniform acceleration or changing acceleration. We've already talked about how to do uniform acceleration. If there's a straight line, we just use a is equal to v minus u over t. But for non-uniform acceleration, we have to do things a little differently. So let's look at this curve. We see right here at time is equal to 0, we have a pretty steep curve, so that's a positive acceleration, and we're thinking it's going to be maybe a larger number. And then at this point, the curve flattens out a little bit, although it is still going up, so we have a positive acceleration, but it's going to be a smaller number than this first section. And then here at the top, it's actually flat, so this would be a acceleration is equal to 0 at this section. The velocity stays the same at this time, so that's 0 acceleration, constant velocity. And then here the object begins to slow down, so the slope of the line is going to be negative, so we have a negative acceleration. So basically we're going to do the same thing we would do with a straight line. We're going to use a is equal to v minus u over t, where v is the ending velocity and u is the starting velocity and t is the time, and we will find the acceleration. In a curve, we can only find it at a particular instant. It's called instantaneous acceleration, and we're given 2 times 12 seconds and 48 seconds. So we want to find the acceleration at 12 seconds. And how we do that is we draw a tangent line to the curve at these 2 times. So I will use a dot, red dot, and I will draw a dot on this curve at t is equal to 12 seconds. So I see in my graph here, each of these boxes represents 2 seconds. So here's 2, 4, 6, 8, 10, 12. So there's 12 seconds. So I go up and I put a dot on the graph at 12 seconds. Now I want to draw a tangent line to that dot. So I'm going to choose a line, make it a thin line, and I'll use green. And what I want to do is draw a line that only touches the blue line at a single point. So I want to try and use my ruler and draw a line that is tangent to the blue line at this t is equal to 12 seconds, this red dot. I want to be careful that I don't cross at 2 points. See, I have crossed at 2 points, so that line is not good. So I'm going to use my ruler and try and draw this line that just barely touches the red dot. And you see right here, I am just barely touching the red dot. The next thing I want to do with my ruler before I draw the line is look to the left and the right of the dot and see if the distance between the green line and the blue line is about the same. And it looks like maybe I've drawn it a little bit off. So I'm going to change my ruler settings a little bit and raise it up and touch the line. And now it looks like the distance between the green line and the blue line, equidistant from the red dot, is about the same. So by changing the line, I've changed the slope a little bit. Okay, so now I want to find a place where the green line crosses my graph paper exactly at an intersection in the graph paper. So if I look closely, I'm looking for a place where the line crosses the graph paper. It looks like it does it right about there. At this intersection, the green line goes right through the graph paper lines. And then that's one point, and I need to find another point anywhere on this green line. It can be over here or wherever. So let's take a look and see if I can find a point that the green line crosses, this one looks pretty good. Okay, so I'm going to use those 2 points for my starting and ending velocity. So my starting velocity, I'm going to use U, I'm going to use U start. U is the starting velocity. And V is the ending velocity. So now I have 2 velocities, and I can find the time between those 2 velocities and find the acceleration at t is equal to 12 seconds. So A is equal to V, the second velocity. So I go to my graph over here, and I follow across to the y-axis, to the velocity, and I see here that these boxes are going up by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this V velocity is at the 22 meters per second on the y-axis. So that's the velocity of V. And then I do the same thing for U. If I go across here, it looks like U is at this point. So that's 11, 12, 13, 14, 15. 22 minus 15 over the time between the 2 velocities. So I'm going to find the time of this, and we already said these are by 2, going up by 2, so that's 42 seconds. 42 seconds minus the value of the time for U, which looks like it is right here at 22 seconds. 22. So I will use my calculator, and I do have a fraction function here. So I'm going to say 22 minus 15 over 42 minus 22. And the answer is 0.35 positive 0.35 meters per second power 2. Meters per second power 2. Don't forget those units. Okay, now I'm going to do the same thing at 48 seconds. Yes, 48 seconds. So I find where on the blue line is 48 seconds. So I have 2, 42, 44, 46, 48. I'm going to put a dot on the blue line, make it a bigger dot, on the blue line at t is equal to 48 seconds. Then I'm going to draw my tangent line. So I get my ruler, and I'm trying to draw a line that's just going to touch the blue line at the red dot. So I drag it out like this. I kind of didn't get it to touch. Maybe that's a little bit like, did I put it right? Okay, so that's, on this graph paper, that's probably going to be as good as I'm going to get. Then I go to find where this green line crosses my graph paper. So I'll use this color this time, and I'm looking for where this green line exactly crosses my graph paper. Oh, I don't really see anything over there. Yeah, I guess this one. And if I keep looking, wow, this one. Okay, there. So I do have 2 points. I'm going to call these points, the first point I'm going to call U for starting velocity, and the second point V for V ending velocity. And then I'm going to use the same equation as before. A is equal to V minus U over T. So A is equal to V. V is here, so if I follow this across, I get a velocity of, and these are going up by 1, so that's 11, 12. V is 12. minus u. U is here. I go across here. I see that I'm at 12, 13, 14. And notice 12 minus 14 is going to be negative. So I am going to have a negative acceleration, which is what I want because the line is going down. It's got a negative slope. For t, I'm going to take the second time, which is right here. Time is by 2, so that's 58, 56 seconds. 56 seconds minus u. Right here. And if that's 56, 54, 52, 52, and that will be positive. So my answer should be negative on top and a positive on the bottom. 12 minus 14 is negative 2, and 56 minus 52 is 4. So that is equal to negative 1 over 2, or negative 0.5. 0.5 meters per second, power 2 for acceleration. I put a video link on the Google Classroom, and I encourage you to watch that to get some tips on how to accurately draw lines. On the final exam, if you are close, that will be correct answer. Okay, let's take a look at question number 2. Question number 2 says, zoom out a little bit here. Question 2, a ball is kicked at an initial velocity of 20 meters per second at 30 degrees to the horizon. Ignoring air resistance, how far did the ball travel and what was its maximum height? So here we have a picture of the trajectory of the ball. We see that it was kicked at 20 meters per second at an angle of 30 degrees to the horizon, and it has traveled some distance and reached some maximum height. So to answer this question, we're going to use sine, cosine, tangent to resolve the sides of the triangle, and then we're going to use this equation. S is equal to ut plus 1/2 at power 2, where S is displacement, u is starting velocity, t is time, and a is going to be the acceleration from gravity. And we can take the acceleration from gravity for all these questions to be negative 9.81 meters per second power 2. So because gravity is pulling things down, we're calling gravity negative. So anything that is going up will be positive, and anything that is going down will be negative. For the height, we're going to use this equation. V power 2 is equal to u power 2 plus 2as, where v is the ending velocity, u is the starting velocity, a is going to be the acceleration from gravity in this case, and s is the displacement, and displacement is in meters. So let's take a look at how we derived these two equations. S is equal to ut plus 1/2 at power 2, and v power 2 is equal to ut plus 2as. Essentially, we've taken the two equations that we already knew. Acceleration is equal to ending velocity minus starting velocity over time, and this equation, ending velocity plus starting velocity divided by 2, is equal to the displacement divided by the time. This is just average velocity, v average, when we're talking about constant acceleration like we have from gravity. And then we rearrange both of these equations to make time, or t, the subject. So here I've multiplied by t and then moved the a underneath, so t is equal to v minus u over a. Here I've put the t over here and the v plus u underneath and the 2 up top, so t is equal to 2s over v plus u. And then I've made these two equations equal because time is equal to time. So I have v minus u over a is equal to 2s over v plus u. Now I want to rearrange this equation and make make v the subject. So I multiply both sides of the equation by v plus u. So I get v minus u times v plus u, which is going to be v power 2 minus u power 2. and then I've multiplied a times 2s. So I have 2as. Then I want to make v power 2 the subject, so I'm adding u power 2 to both sides. Minus u power 2 plus u power 2 becomes 0, leaving me with just v power 2 on this side is equal to u power 2 plus 2as. You don't need to know how to derive the equations, but it would be easier just to memorize these equations. And here for the displacement equation, I do the same thing, but this time I'm making v the subject. So I have a is equal to v minus u over t. I multiply both sides by t, and I get at is equal to v minus u. I want to have v as the subject, so I add u to both sides. So v is equal to u plus at. Over here, I'm going to multiply both sides by 2, leaving me v plus u is equal to 2s over t. And then I subtract the u from both sides, leaving me with v is equal to 2s over t minus u. And now I have v and v, so u plus at is equal to 2s over t minus u. U plus at is equal to 2s over t minus u. I added u to both sides to get rid of this u. So now I have 2u plus at is equal to 2s over t. Then I multiplied both sides by t. So 2s over t times t, the t's cancel, leaving me with 2s. And then I have to multiply t by everything over here. So 2u times t is 2ut, and at times t is at power 2. So 2ut plus at power 2 is equal to 2s. And then I divide both sides of the equation by 2. The 2's cancel, leaving me with s. 2ut divided by 2 is just going to be ut, and at power 2 divided by 2, we're going to write it as 1/2 at power 2. So the first thing that I want to do in this sort of equation, this sort of problem, is to resolve the triangle. I want to resolve the triangle into its parts. So I have the one side, the hypotenuse, and then I have the angle of 30 degrees. So basically I'm just going to draw a right triangle, and I'm going to label this side as 20, and that's meters per second, meters per second. And the angle is given as 30 degrees. So I want to find the value of this side of the triangle and the value of this side of the triangle. So we're going to call this velocity in the y-axis, or the vertical velocity, And this side we'll call velocity in the x-axis, or the horizontal velocity. So if we have a side and an angle, we're going to use sine, cosine, tangent. In this case, I want to use sine, which is so, meaning sine is equal to the opposite over the hypotenuse. So I have sine of 30 degrees is equal to, the opposite, the side opposite the angle, which in this case is the velocity in the y-axis, which is what I'm trying to find, over the hypotenuse, which is the side opposite the 90-degree angle, 20. So if I rearrange the equation for v sub y, I get 20 sine of 30 degrees, 20 times sine of 30 degrees, and I just happen to know the sine of 30 degrees is 0.5, so v sub y, I put that in the wrong place. Let me move that. V sub y is what I'm talking about, is 10 meters per second. What does that mean? The velocity in the vertical of the ball is 10 meters per second positive. So if we were to look at this ball being kicked from behind the person kicking the ball, if you could imagine being here and watching the ball, we would see the ball moving up, and it would move up 10 meters per second, and then we would start to see the effect of gravity pulling it back down gradually. So this v is equal to 10 is the velocity in the up and down, or the vertical. Next, I want to find the velocity in the horizontal. So if I were to look at this footballer from the roof of the stadium, I would see that the ball is moving the same distance per unit of time, because gravity is not pulling the ball this way. That would be air resistance, and we're ignoring air resistance. So the ball is going to travel in the horizontal with a constant velocity. And so I'm going to try and find out what that velocity is. So now I have a few choices. I could use a squared plus b squared is equal to c squared. I could use tangent. I could use cosine, and I'm going to use cosine. So cosine of 30 degrees is equal to, and for cosine we have ca, which is the cosine is equal to the adjacent, or the side that is next to the angle but not the hypotenuse. So this is the adjacent angle, which is what I'm trying to find, which I'm calling v sub x, for lack of a better letter, over the h, which is the hypotenuse. So v sub x is equal to 20 cosine 30 degrees and so I'm going to use my calculator here. Oops, did I close my calculator? I think I closed my calculator. Let's try here. 20 cosine 30 degrees, and that gives me 17.32. 17.32. So the velocity in the x-axis is equal to 17.32 meters per second. Meters per second. I'll write it here, 17.32. So once I have resolved my triangle, the next thing that I want to do is find the time that the ball was in the air. So we had the ball being kicked, and we found that the velocity was 10 meters per second in the vertical. And I also know that gravity is pulling that ball back down, and the acceleration from gravity is negative 9.81 meters per second, power 2. Next, I know the displacement. And remember, displacement is the vector quantity of distance. So for example, if I drive to Chiang Mai and do some shopping and then come back, well, the distance to Chiang Mai is 100 kilometers. So if I drive to Chiang Mai and then come back, I traveled a distance of 200 kilometers, 100 kilometers there and 100 kilometers back. But my displacement is the distance between where I started and where I finished. So my displacement on this trip is 0. I drove 100 kilometers, yes, to Chiang Mai and drove back, but I ended up where I started. So my displacement is 0 meters. And that's what's happening to this ball in the vertical. It went up and it came back down. Now I know it traveled a distance, but we're not talking about that distance. We're only talking about in the vertical component of the journey of the ball. So I have V, I have A, and I have S. So I can use the equation S is equal to U which is going to be our v sub x, because u is the starting velocity, which is what I've used here as v sub x. It started out going up at 10 meters per second in the vertical. The rest of the equation is plus 1 over 2a, and this is the acceleration of gravity, times t power 2. Put in the numbers that I know. 0 is equal to 10. And I don't know t. I'm trying to find t, so I leave that in there. Plus, and I have 1/2 times negative 9.81, which is negative 4.905. Half of negative 9.81 is negative 4.905, and then I have a t power 2. And I want to know, excuse me, what values of t will make this equal to 0. So you might say, well, t is equal to 0. 10 times 0 is 0, and 0 squared times that is 0. That's true. The displacement of the ball is 0 right when he kicks the ball, but that's not going to help me. I need to know the time at the end of the journey of the ball. So what I'm going to do is I'm going to rewrite the equation and factor out a t, which means I'm going to take a t out of both of these terms. So I have 10, I took the t out of there, minus 4.905. And before I had t power 2, but I'm taking one of those t's out and putting it over here. And so now I have this. So I would have, if I were to multiply this out, I would still get 10t minus 4.905 t power 2. Now I'm going to divide both sides by t. Divide by t. T divided by t will be 1, so that will leave me with 0 divided by t is still 0. 0 is equal to 10 minus 4.905 t. And I want to solve for t, so I'm going to rewrite this equation. What did I do? I moved the 10 to the other side, so that's going to be negative 10. And then I'm going to divide by the coefficient, or the number in front of t, which is negative 4.905. Go back to my calculator. So I have negative 10 divided by negative 4.905, and I get a positive, because a negative divided by a negative is a positive, 2.038. I'm going to say 2.04. 2.04. T is equal to positive 2.04. Time, the unit of time is seconds. All right, SEC. Now I have the time that the ball is, traveling. But it doesn't ask for the time, it asks for the distance and the height. So for the distance, I know the journey of the ball from the kick all the way to the landing is 2.04 seconds, and I also know the horizontal velocity is 17.32 meters per second. And because we're ignoring air resistance, it's going to travel 17.32 meters every second for this 2.04 seconds. So for this, I can just use v is equal to the distance, or the displacement. I'm going to say s for displacement. That's not speed, that's displacement, vector distance, over the time. So the velocity in the horizontal was 17.32 meters per second. I want to know s, and the time I just found as 2.04. So to solve for s, I multiply 17.32 times 2.04. Oops. 17.32 times 2.04, and that gives me 35.33 meters. 35.33 meters. So that is the answer to the first part of the question. How far did the ball travel? The next part of the question says, what was its maximum height? How high did the ball go in its journey? And that's going to happen right here at the highest point of the arc. And this happens at half of the total time. So if I call the 2.04 seconds the time total, which would be right here, 2.04 seconds, the time right here is going to equal, I'll call this t sub 1, half of that. So half of 2.04 is 1.02 seconds. And that makes sense. The beginning of the journey will look just like the end of the journey. So at the halfway mark, that will be the highest point of the ball's journey. So I know the time that I'm going to use is equal to 1.02 seconds. And I know gravity is going to be a factor here because the ball is going up. So gravity is equal to negative 9.81 meters per second power 2. And I know the starting velocity, and this was what I called v sub y, the velocity in the vertical. Now I'm going to call it starting velocity, and we said that was 10 meters per second. By resolving the triangle and finding this vertical component. Excuse me. And I also know the ending velocity. So when we're talking about this perspective, as we see the ball, we would see the ball move up and up and up a shorter and shorter distance until at some point it would seem like the ball just hovered in midair and did not go up or down, but just stayed right where it was. And that's going to happen at this apex time, or at the halfway point in time. So at that time, the velocity of the ball will actually be 0. It's not going up and it's not going down. So we're going to call that the ending velocity is equal to 0. So now I have A and T and U and V. So I'm going to use my second equation. V power 2 is equal to U power 2 plus 2AS. And I'm going to solve for S, the displacement. And that will tell me how high the ball went. So V power 2 is equal to U power 2 plus 2AS. V is 0, so 0 power 2 is 0. U is 10, so 10 power 2 is 100, plus 2 times gravity. And gravity is still negative because it's pulling the ball down. It's acting opposite to the upward direction of the ball. S. So I rearranged the equation for S. So the first thing I'm going to do is move this 100 over to the other side. So I get negative 100. And then I'm going to divide by the number in front of S, which is 2 times negative 9.81, which will be negative. So a negative divided by a negative will be positive. So that's going to be negative 100 divided by 2 times negative 9.81. 5.096, which will be 5.10 meters. S, in this case this is the height, is equal to 5.10, and the unit of displacement is meters. We should say direction, but it's implied that height is up, so we don't have to say up. Okay, I will link a video showing more information about this kind of question. Question number 3 is very similar to number 2, but now we have the ball or the stone being thrown from a cliff. So the question says, a stone is thrown off a cliff of height 50 meters at 20 meters per second at 45 degrees to the horizon. How far did the stone travel? And here we see the picture. The person is on the cliff. The cliff is 50 meters above the ground. The stone was thrown at an initial velocity of 20 meters per second at an angle of 45 degrees to the horizon. And this dotted line kind of shows how that stone would fly through the air. And the question is only for what is the distance. So, to solve this question, we cannot factor out t like we did in this question when we got to this point. S is equal to ut plus 1/2 at power 2. The displacement, because the ball ended up where it started, was 0. In this question, the displacement is not 0, so we have to use the quadratic formula, and so we'll look at how to use that in this question. But first, same as before, we must resolve the triangle into its components. So I have a 45-degree angle and a 20 meter per second hypotenuse or initial velocity. So this is 20. This is 45. It is a right angle. So I can use Pythagorean, or I can use sine, cosine, tangent. Why don't I just say sine? Sine of 45 degrees is equal to the opposite, and I am going to say v sub y and v sub x again. So if I'm talking about sine, I'm talking about v sub y, velocity in the vertical, over the hypotenuse, which was 20. Rearrange the equation, I get v sub y is equal to 20 times the sine of 45. Let's take a look at that. 20 times the sine of 45. And notice that I am in degrees. Make sure you're in degrees. And that'll be 14.142, and we'll round that to 14.14. 14.14. And we are talking about velocity, and the unit of velocity is meters per second. Because it's a 45-degree angle, these will both be the same value. So the vertical and the horizontal are both 14.14. And the velocity in the horizontal is also 14.14. Now, I'm going to solve for time. So to do that, I'm going to use S is equal to ut plus 1/2 at power 2. So the first thing is displacement. For the displacement, and remember we are talking about in the y-axis or the vertical axis, the ball started here and it's going to end up down here, although it's going to be displaced in this direction, but we're only concerned about the travel of the ball in this y-axis. So this is down. we are 50 meters below where we started. So S is going to equal negative 50 meters, because if it's going down, it's negative. So S is 50 meters. The starting velocity is this v sub y, this velocity in the y-axis, or this vertical velocity, which we said was 14.14. And I'm trying to find t, so I'm going to put in t, and then I have plus 1 over 2a. So I'm just going to write minus 4.905, which is half of 9.81, and then t power 2. Now, I cannot, like I said, I cannot factor out a t because it's not equal to 0. So what I have to do is I want to rewrite the equation in this form, where I have 0 is equal to a, and that's just a variable for the coefficient of the power 2 variable. At power 2 plus bt is equal to c. So the power 2 is here, t power 2. So I'm going to move this 50 over to the other side by adding 50, which if I add 50 to both sides, it means that's going to be 0. But I do want to write this t power 2 first. So I have negative 4.905 t power 2. Then comes just the t power 1, b being the coefficient in front of t. So for t power 1, I have 14.14. So that's plus 14.14 t. And then the c is this number over here because it didn't equal 0. So what I did is I moved this negative 50 over here by saying plus 50 to both sides. So this is going to be plus 50. And now I have it in a form that I can use the quadratic equation. So here it is. 0 is equal to negative 4.905 t power 2 plus 14.14 t plus 50. And so we call the number in front of t power 2 a. And this is not acceleration a, it's just the a for this equation up here. The number in front of t power 1 is 14.14, and that's going to be b, which we see here. And then the last number is c, which is here in the equation. So I'm going to plug in these values for a, b, and c into the quadratic equation, which is negative b plus or minus the square root of b squared minus 4ac over 2a. And we do have to do it with a plus, and then we have to do it again with the minus. And the idea is that we want to have a positive answer for time. We will get a negative answer for time, but that's not what we're concerned about. The negative answer would be, well, yeah, if he kicked the ball over here at some negative time, but we're not concerned about that. We want to have the positive value of time. So, go to the calculator. We had negative b I'm going to use a fraction. Negative b, negative b, b is 14.14. 14.14. I'll do the plus first. Negative b plus square root. And I do want to put this in parentheses, so it will take the square root of everything that I'm going to write here. B power 2. So b again is 14.14, and I want to square that, minus, and then this 4ac, I want to put that in parentheses as well, so it will multiply all those things together before subtracting. So that's 4 times a, which is this a, not acceleration a, but the a in front of the coefficient of the power 2 variable, so that's negative 4.905, and then C, so times 50. I need to close up here, so I have 1, 2 opens. I need 1, 2 closes. Over 2 times A. And again, A is negative 4.905. And I get a negative answer. So that is that's the negative time, and that's not what I'm concerned about. So I want to change this plus, because it is plus or minus. I want to change that plus to a minus. And when I change that plus to a minus, I get 4.944, or 4.94. So T is equal to 4.94 seconds. The stone is in the air for 4.94 seconds. But that's not what the question is asking. It's asking for how far the stone traveled. But again, like the other one, if we look at it from the perspective of above, we would see, ignoring air resistance, that the ball would travel the same distance per unit of time, because gravity is not pulling the ball in this direction. Air resistance, which we're ignoring. So we just use the V is equal to D over T, or V is equal to S over T, I should say. Velocity is equal to the displacement over the time that the stone was in the air. So this is the velocity in the horizontal, which we said was the same, 14.14 meters per second, is equal to the displacement, which I'm trying to find, over the time, which we just found was 4.94 seconds. So S is equal to 14.14 times 4.94, which comes out to 69.85, 69.85 meters. Don't forget your units. Okay, I will link a video on how to answer these sort of questions in your Google Classroom. Please watch those videos, and good luck on your final. Thank you so much, and